Most of the reported side effects for NAD precursors like NAM, NR, and NMN are relatively rare and minor, for example, diarrhea, nausea, rashes, hot flashes, and leg cramps. Both NR and NMN raise NAM levels, so may share in the same concerns regarding sirtuin inhibition, methyl depletion, and potential adverse effects of NAM breakdown products. Another theoretical concern of NAD boosting is the exacerbation of infections by a group of bacteria called Haemophilus, from the Greek meaning blood-loving, though can also cause infections of the lung, brain, throat, flesh, and joints. Haemophilus bacteria lack the ability to make NAD, so rely on host levels, raising the possibility that higher blood levels might worsen the disease course of infected individuals. Ironically, elevated NAD levels may also fuel immune system overreaction in cases of autoimmune and inflammatory disease. When fully activated, the immune system is voracious. The immune reaction to a blood infection or extensive burns can burn 4,000 calories a day, approximating military training in the Arctic. Since NAD is used by cells to produce energy, it's no surprise that we find the primary NAD synthesizing enzyme strongly upregulated in tissues that are actively inflamed. For example, the enzyme NAMPT is elevated in colonoscopy biopsies taken from inflamed areas in patients with inflammatory bowel disease, and higher levels are correlated with greater disease severity. So, for those suffering from chronic autoimmune diseases such as rheumatoid arthritis, NAD boosting could potentially have a profound negative impact. This explains why tamping down NAD with NAMPT inhibitors has been shown to ameliorate colitis and arthritis in mice, but this is yet to be tested in people. Such NAD-depleting drugs have, however, been used in cancer patients. Malignancy is another heavily energy-consuming process. NAD may therefore have a tumor-promoting effect by promoting cancer cell growth and spread. For example, NAMPT, the NAD-forming enzyme, is highly expressed in cancerous brain tumors and correlates with decreased patient survival. This has led to attempts to use NAD-depleting therapies to try to starve cancer progression, but this approach is confounded by rapid onset injury to another energy-intensive tissue, the retina, risking blindness. Giving NMN to mice with pancreatic cancer accelerates the progression of the cancer, thought due to the aggravation of inflammation. The researchers conclude that consumers of NAD supplements must balance the advantageous anti-aging effects with the potential detrimental pro-tumorigenic side effects. Perhaps this explains why the best NAD boosters have ever been able to do is increase mice lifespan by 5%. On the other hand, as you'll remember, NAM successfully prevented human skin cancers, and has been found to reduce the incidence of a variety of carcinogen-induced tumors in rodents. The disparate results may in part be due to the disparate impact sirtuin activation may have on different cancers. Sirtuin activity can be overexpressed in some cancers, like thyroid carcinomas and lung metastasis, but reduced in others, like brain, bladder, prostate, and ovarian tumors. The bottom line is that particular caution should be used for NAD-boosting supplements by those with cancer, or a personal or strong family history of cancer, and perhaps also by those with inflammatory disorders and certain active infections.